Today we are going to talk about reference angles. Reference angles are just a quick way for us to find values of like sine of negative 135 or whatever value you are looking for. So it's a quick way for us to get values. The reference angle is an acute angle formed by the terminal side of theta and the x-axis. It's very important. You always measure from the x-axis. And anytime I'm doing this, I'm always going to start with a picture. So if you look at my first example is pi over 3. So if I start, I know, 5 pi over 3. I start with my coordinate plane. I know if you're better with degrees and you want to put it into degrees, that's fine, but when you put your final answer, it has to be in radians. You want to put it however they give it to you. Those of you that are familiar with your unit circle, you know that 5 pi over 3 is here. So what the reference angle is from here to here. So you're taking your angle that you're given here and you're going back to the x-axis the quickest way. So I want to figure out how can I get from here to here. Well, I know this is 5 pi over 3 and this is 2 pi. Well, if I put 2 pi in terms of a denominator of 3, that's 6 pi over 3. So if I do 6 pi over 3 minus 5 pi over 3, I'll get my reference angle as pi over 3. We label our reference angle with a theta and a prime symbol. So my reference angle then is pi over 3. If I try negative 130, okay, so I know negative 180 is here, negative 90 is here, so negative 130 is here, and I'm going this way. So the quickest way, which is my reference angle, is here. I know this is negative 180, so really all I'm doing is 180 minus 130 to get that my reference angle is 50. So I like to think of it as you're looking to get back to either 360, 180, or negative 180, or in terms of radians, pi and 2 pi. So if you check out the next page, there are 6 for you to try. I'm going to pause the video and you can try all 6 of these, and you should be able to do them. Make a sketch first. Make a sketch first. So 15 pi over 4 is going to be very close to 16 pi over 4, which is 4 pi, which would be going 2 times around my unit circle. So I know I am in here. So this is 15 pi over 4. The closest thing would be getting me back to 2 pi. Well, that's 16 pi over 4 here in terms of 4. Or 4 pi and 2 pi are the same thing. So then I'm going to take 16 pi over 4 minus 15 pi over 4 to get pi over 4 as my reference angle. So I'm going to quickly go through these ones and hope that you are getting them as well. So one thing that, hopefully you were able to check those out, one thing you want to know is that reference angles allow us to evaluate all 6 of our trig functions given any angle of theta. So the sign of the function depends on the quadrant in which it lies. So here's what you want to know. I'm going to write this out and then I'll explain what it means. In quadrant 1, everything is positive. Oops. In quadrant 1, everything is positive. In quadrant 2, sine is positive. So then sine's going to be positive, and then cosecant is going to be positive. In quadrant 3, tan and cotangent are positive, and in quadrant 4, cosine and secant are positive. So in quadrant 1, everything is positive, all 6 trig functions. This is very important to understand. Alright, and then the next type of examples I'm going to do is you're just going to see where they say evaluate the following values. And they ask you to take the tan of negative 240. Well, I want to find the reference angle for 240. So if I graph 240 on negative 240 on my coordinate plane, I know I'm going to be, this is negative 180, negative 270, so I'm going to be in here. So this way is negative 240, so then I need to go back to my 180. So if I take 240 and I subtract 180, that gives me 60. So my reference angle then is 60 degrees. So now I need to find tan of 60 degrees. Well, tan is just sine of 60 over cosine of 60. Thinking back to my unit circle, either using your hand or knowing and understanding your unit circle, I know that sine is square root of 3 over 2, and cosine is 1 over 2. So then if I multiply by the reciprocal here, I'll get the square root of 3. But here's where you have to check back to that chart or that graph that I just made saying what's positive, what's negative. I'm in quadrant 2. So in quadrant 2, I know that sine is positive. So this sine is going to be positive and this is going to be negative, so I know that my tangent is going to be negative. So my final answer is negative square root of 3. I'm going to let you try B and D on your own. I'm going to do one more with you. So they're looking for the cosecant of 17 pi over 6. So if I find the reference angle, 17 pi over 6 is going around going around once. Getting my 2 pi would be 12 pi over 6, and then having 5 pi left over. So 5 pi over 6 would be here. And then my reference angle, well, this is 5 pi over 6, and I know this is pi, so all I'm going here is just pi over 6. So my reference angle is pi over 6, so I'm looking for the cosecant of pi over 6. Well, I know cosecant is 1 over sine of pi over 6, and then pi over 6 of sine is just the square root of 3 over 2. So if I'm taking 1 over that, I'm going to flip it to get 2 over the square root of 3. Get rid of the radical, so I get 2 square root of 3 over 3. Before I decide if this is my final answer, I need to remember I'm in quadrant 2. So if I go back to my little chart, I know sine and cosecant are both positive. They wanted cosecant, so I know this is going to be positive, so this is my final answer. So I'm going to let you try B and D right now on your own. For B, you should have gotten your reference angle as 45. So when you took sine of 45, it would have been the square root of 2 over 2. Now I have to remember, is this my final answer? Well, in quadrant 2, sine is positive. This was in quadrant 2, so this is my final answer. With D down here, you should have gotten your reference angle as pi over 3. So when you took cotangent of pi over 3, you would have gotten the square root of 3 over 3. Now I'm in quadrant 4. Quadrant 4, cosine and secant are positive, meaning that cotangent is negative. So my final answer here is negative square root of 3 over 3. Alright, in my last example here, I'm going to let you read through this. So the most important thing here is the equation. If they give you your degree, your theta in degrees, you can stay in degrees, just make sure your calculator is in degrees. And then understand that V is your initial speed. So here, this is literally just plugging into my equation. In this equation, you're going to want to remember or write down for your homework. It is on that as well. So this is then just 32 squared. Nope. This is just 16 squared, your initial speed, over 32, times sine of 2 times 45. 16 squared gives me 256 over 32. Sine of 90. Well, I know the sine of 90 is 1. And I know that 256 divided by 32 is 8. So this is 8 times 1, or 8 feet. So pretty much just plugging it in, understanding your trig functions here. So now you're going to work on 13.3 practice B. You're completing that entire 13.3 practice. I have posted the answers online for you to check it out if you need it. Do not do the book work, complete this, and I will see you tomorrow.